In this video, we are trying to discuss the formation of one of the extrinsic semiconductors known as N-type semiconductor. N-type extrinsic semiconductor. The conductivity of an intrinsic semiconductor is very low. Even the conductivity is highly temperature sensitive. Increase in temperature can give more electrons exciting from valence band to conduction band. Reduction of temperature can lead to less number. Even at 0 Kelvin, it acts as an insulator. So the conductivity is very low and it highly depends on the temperature. So we cannot rely on the conductivity of an intrinsic semiconductor. It's not guaranteed. That are the two limitations of intrinsic semiconductor. The solution for this is known as doping. Adding external elements so that the conductivity of intrinsic semiconductor can be enhanced. Even it can be made less temperature sensitive. That process of adding external elements known as impurity atoms to increase the conductivity of an intrinsic semiconductor is called doping. Doping is normally done in parts per million, and the doped semiconductors are called extrinsic semiconductors. The type of doping decide N-type or P-type. Now, ppm parts per million. 1 ppm doping means one impurity, one external element is added for every million silicon or germanium atoms. So 5 ppm doping means 5 external impurity atoms are added for each 1 million silicon or germanium atoms. The silicon or germanium are group 14. They have 4 covalent bonds with the neighboring silicon or germanium atoms. So this is what you call doping, which helps to increase the conductivity of an intrinsic semiconductor. Now we are going to the type of the semiconductor. Here we are discussing the formation of N-type semiconductor, N-type extrinsic semiconductor. Group 15 elements are added into group 14 for the formation of N-type semiconductor. Group 15 like antimony, arsenic are added into group 14 silicon or germanium, replacing one silicon or germanium group 14. Group 15 atom comes in its place. So group 14 silicon germanium crystal structure demand 4 bond formations with the neighboring 4 silicon or germanium atoms. When a 4 atom, the group 15 atom comes replacing one silicon atom, the structure still demands 4 bond formations, but the group 15 atom, the antimony or arsenic, has 5 valence electrons. So out of the 5 valence electrons, 4 valence electrons are used for bond formation with neighboring 4 silicon or germanium atoms. The 5th electron, which is not involved in any bonding, can become free by absorbing very less thermal energy. So this is the structure of silicon. Silicon form covalent bond with all neighboring 4 silicon atoms. This is assumed to be silicon. But when you replace one silicon by an antimony or arsenic, now this atom has 5 valence electrons. 4 are used to form bonds with 4 neighboring silicon atoms, one from silicon, one from arsenic or antimony. So 2 electrons, one each from silicon and arsenic or antimony. So like that, the bond formation is complete, it's stable in the structure, but the fifth electron which absorbs thermal energy can become a free electron. This happens without creating a hole, because a hole is created only when a valence electron, the electron in the bond, is leaving. Here the fifth electron, which is not involved in any bond formation, is leaving, so it don't create a hole, but it gives a free electron. Every group 15 atom doped will provide one free electron without creating a hole. So each group 15 donate one electron free without forming a hole. Other than this doping effect, there are free electrons and holes formed in silicon crystal also, that will be forming equal free electrons and holes. So holes are only formed due to thermal excitation from silicon atoms. Free electrons are formed due to thermal excitation from silicon atoms as well as donation by group 15 atom. So free electrons becomes more in number compared to the holes. So free electrons are the majority charge carriers compared to holes larger in number. The holes are minority charge carriers. That means Ne is greater than NH. The product of Ne and NH always follow the rule Ne into NH equal to Ni square, where Ne and NH are the free electron and hole concentration after doping. Ni is the free electron or hole concentration before doping, which was equal for an intrinsic semiconductor before doping. So this is the mathematical side. We have to be taking care of for numerical side also. Now, even though free electrons are exceeding the holes, N-type semiconductor is electrically neutral. Normally, this is a misconception. When electrons are greater than holes, generally the substance has to be electrically negative. But system is electrically neutral because before doping, the free electrons and holes are formed equal in numbers. So Ne equal to NH before doping. So the total charge is balanced. After doping, one electron becomes free for conduction. When the electron leaves this atom, that atom which was neutral initially becomes a positive ion. So for every electron donated by group 15 atom, the group 15 atom becomes a positive ion. So the electron just go out, and the negative charge is balanced by the positive charge of the group 15 becoming a positive ion. So the system is electrically neutral. Now, if it's not clear, the clarity comes from here. Before doping, there are free electrons and holes formed equal number. This free electron and hole is formed before doping. This free electron and hole is also formed before doping. Now, when you dope, the group 15 atom releases one electron free. Even though it don't create a hole, as it leaves the atom, that atom becomes a positive ion. Same way, these four are the group 15 atoms. All group 15 atoms donate one electron free by the group 15 atom itself becoming a positive ion. So each electron represented by the filled dot, and each hole represented by the empty circle, and the plus with circle around it represent the positive donor ion. So if we count the dots which are negative, 1, 2, 3, 4, 5, 6 negative charges, 4 plus of the ions and 2 plus of the holes. The total 4 plus 2 positive, 6 negative charges. So the total positive charge is equal to total negative charge. hence the system is electrically neutral. Thank you for watching.